These are your guided notes for lesson 5.5. There is a lot of information, a lot of trying to connect dots to past knowledge in this lesson. Try to make it as clear as I can. We'll certainly follow it up in the classroom with class discussion and work some problems out together. So your I can statement at the top. I can find the slope when given a pair of coordinates. I can find the slope when given a pair of coordinates. So a lot of information as we go through these notes. First vocabulary term in there's an important one, slope. So your slope is the rate of change. It's the rate of change between 2 points on a line, the measure of the steepness of a line. So I think we've all used the word slope in describing how steep or shallow something is. The pitch on a house's roof, things like that. So it's the rate of change between 2 points on a line, the measure of the steepness of a line. And here's what slope is mathematically. Slope is your change in y over your change in x. And change in math means subtract. So all we're doing here is we're going to have two subtraction problems. We're going to have one subtraction problem on the top where we're subtracting two y values, and we're going to have a subtraction problem on the bottom where we're subtracting two x values, and then we're going to get a fraction with those two differences. So slope is also referred to as rise over run. Obviously rise being the change in your vertical, run being the change in your horizontal. So if we take a look at a couple of practice problems here. Example 1 says to find the slope of each line. So again, if we go back to the definition, it's the change between 2 points on a line. And in example 1, they give us 2 points. They give us 0, 0 and 5, 2. So 5, 2 and 0, 0. Those are the 2 points. So what we're trying to find out is how steep or how shallow is that line on the graph. So again, change in y. Remember, ordered pairs are always x, y. Always. So the x number is first, and the y value is always second. So on top, we're going to subtract the two y values. So our y values are 2 and the 0. And our x values are the 5 and that 0. So on top, I'm going to subtract the first y, 2, minus the second y value, which is 0. And on the bottom, I'm going to subtract the x's, which will be 5 minus 0. So 2 minus 0 is 2, and 5 minus 0 is 5, and that is your slope. So your slope, your change in y over your change in x, is 2 over 5, which means this. So again, it's your rise over run. So it means if I start at 0, 0, and I go up 2, so I go up 2, and then I go right 5, I will be on the line again. And I can continue to do that forever. I go up 2, right 5, or, and it would be off the graph here, you could go down 2 and then left 5, and it's always going to be the same. It doesn't matter which order you subtract them in. Doesn't matter what order you subtract them. So I subtracted 2 minus 0 on top. You could have it the other way around. You could have 0 minus 2. But if you do that, you need to make sure you're subtracting them in the same order. So I had 5, 2 written and 0, 0. So if I do this first minus the 2, then I have to do this x minus that x. I have to keep that order. So I would do that. I would get negative 2 over negative 5. And when that happens, if I have a negative over a negative, those negatives cancel, which still gives me 2 over 5 as my slope. So if you think you got it, give example number 2 a try. Hit pause. Give number 2 a try. See if you can get it correct. So again, ordered pairs are always x, y, 1, 5, and 2, 8. So again, does not matter which order you subtract them as long as you're consistent. So the y's, though, must be on top. So if I do 5 minus 8, then on the bottom I have to have 1 minus 2. And I do that subtraction, and I would get negative 3 over negative 1. And like we just talked about, the negatives would cancel each other, leaving me with 3 over 1, or 3, as my slope. And again, if I start anywhere on that line, anywhere, and the top number is my change in rise, which is 3. So if you were to go up 3, so my red dot there is on 3. So if I go up to 6, and then right 1, I'll be back on the line. Okay, so that's all slope is. It's your rise over your run. Rise over run. So now they're asking us to graph these. So you have your ordered pair. Pay attention that it's the x value on top and the y is on the bottom. So as ordered pairs, we'd have 0, 0, 2, 10, 4, 20, 6, 30, 8, 40, and 10, 50. So obviously we can't use the whole numbers 1 as to number those. So on the y value, the y-axis, which is the vertical one, you probably want to count up by tens. So it's tough for me to write with this in there, but that first line would be 10, next one would be 20, then 30, next one 40, and then 50. And on the x-axis, this is your x-axis, I'd go up by 2. So the first line is 2, and then 4, 6, 8, 10. So I'd number it like that. With your pencils, it'll be easier to number. And then graph those points. 0, 0 would be right there at the origin. 2, 10 would be right there. 4, 20 be there. And you can just follow your way up. 6, 30, 8, 40, and 10, 50. And then use a straight edge. It's important that you keep your work neat. So find a straight edge, corner of a folder or a ruler. Connect your dots, and then put an arrow at the end. And if you remember from previous lessons, that line crosses through the origin, and it's straight, which means it's proportional. Crosses through the origin, and it's straight, which means it's proportional. So for the next page here, we have to flip back for step 2. It says choose any 2 points on the slope of the line, find the change in y and the change in x, then simplify the ratio down to a unit rate. If you remember unit rate, that means the denominator must be 1. So I flip back, pick out any 2 points. I'm going to choose 210 and 420. So write it down here. I'm going to choose 2, 10. You can choose whichever ones you want. And 4, 20. And I'm going to find the slope. And if the slope ends up having a denominator of 1, I'm good. If it doesn't, then I need to change it so that it is 1 because it's asking me to write it as a unit rate. So I'm going to have 20 minus 10. And if I do 20 minus 10, then I have to do 4 minus 2. 20 minus 10 is 10. 4 minus 2 is 2. And I would simplify that to 5. They're both divisible by 2. So I would get 5 over 1. And that's my slope. My slope is 5 or 5 over 1. The directions, however, want us to write it as a unit rate. So I go back, and I see I have hours and dollars. Hours and dollars. So we remember money always goes on top, and time always goes on the bottom. So if I go back to this one, I have money on top and time on the bottom. So unit rate would be $5 per hour. We have to write that out since they want it written as a unit. So the next problem that we're going to graph says to graph the line that passes through the 2 points. They're down here. On the numbering of the number lines now, 0, 0, that's easy. We know it's going to be at the origin. And we're graphing 1/3, 7/3. So I wouldn't number these numbers by whole numbers. The x value, I would go up by thirds. So the first line I would make 1/3. Second line, 2/3, 3/3, 4/3, 5/3, and so on. And I would do the same thing on the y. So first line going up is 1/3, 2/3, 3/3, 4/3, 5/3, and the very top line would be 7/3. Hopefully that makes sense. Each line, instead of representing one whole unit or counting up by tens, we're counting up by 1/3. So it makes it easier for us to graph it. So there's 0, 0 at the origin, and then 1/3, 7/3. So from the origin, I go right to the 1/3, and I go up to the 7/3, which would be right there. You can see this is a pretty steep line. Use a straight edge to connect those two dots, extend it, put an arrow past it. It says then find the slope of the line. So again, that's doing the subtraction, the change in y over the change in x. So I always would rather do, minus 0. So I would have 7/3 minus 0 over 1/3 minus 0, which would give us 7/3 on top and 1/3 on the bottom. From here, we'll discuss this in class to clean this up. But from here, when we have slope, we can't write slope as 7/3 over 1/3. We can't have that complex fraction like that. One thing that you could try, and it'll end up working out for us, is to get the denominator to be 1. If I have 1/3, if I multiply that by 3, that would give me 3/3, which is 1. And if I multiply the bottom number by a 3, I have to multiply the top number by 3. So 7/3 times 3, which as a fraction is 3 over 1. I would cross factor. 3 divides itself once, and 3 divides itself once. 7 times 1 is 7. 1 times 1 is 1. 7 over 1 is 7. So I get 7 over 1, or 7, as my slope. Okay, we just can't leave it in that format like that is all. And we can clean that up a little bit tomorrow in class. From here, you've got your do on your owns. Finish those up, and we'll discuss this in class.